Hi, my name is Somojit Chatterjee. I am a research scholar from the Department of Computer Science and Engineering, IIT Kharagpur, India. Here, I'll be talking about our short paper, AmicroN, a framework for generating microactivity annotations for human activity recognition. Complex activities of daily living are often composed of multiple smaller microactivities. These microactivities tell us a lot about the cognitive states of a human being. For example, steady incoherence in performing daily activities can actually be an indicator of an underlying medical condition like dementia or mild cognitive impairment. However, developing such activity recognition systems with varying granularity is difficult primarily because of the lack of labeled data, especially when the task of annotation surrounds the labeling of intricate microactivities. Understanding this, we in this paper develop AmicroN, a framework that can automate the generation of microactivity annotations by expanding a coarsely labeled dataset. Before jumping into the design of AmicroN, let's first understand the fundamental challenges in developing such a system. The first challenge is that unless it is pre-specified, the composition of an activity may not be known a priori. Subsequently, the number and exact pattern of microactivities may be difficult to search within a complex activity. This certainly limits the application of supervised learning in these cases. Following these challenges, we devise a strategy using the zero-shot approach to facilitate defining unknown activities and use unsupervised change point detection to locate the key actions within a complex activity. To achieve this, in this paper, we exploit the short duration macro activities from the pre-labeled dataset to train the zero-shot model and then use that model to generate the microactivity annotations for longer duration complex activities. It is noteworthy to mention here that AmicroN takes locomotive signatures as the only unimodal input to the framework. The design details are as follows. The entire framework is designed to work in two separate phases. First, the training phase, where we first segregate the short duration activities and use their existing labels to train the zero-shot model using something known as verb attributes. And second, the prediction phase, where the trained model works on specifically identified change point windows to predict the corresponding microactivity annotation. More specifically, we design the zero-shot model as an array of classifiers, with each classifier considering labels from a particular dimension of the semantic embedding. Focusing on semantic embedding in this paper, we use verb attributes that exploit dictionary definitions from the different verbs to generate meaningful embeddings automatically. Next, in the prediction phase, the locomotive signatures for each longer duration complex ADL pass through change point detection mechanism that detects the windows and subsequently uses the patterns averaged across each window as an input to the trained zero-shot model for prediction. Finally, we evaluate the framework on the publicly available kitchen dataset containing data from 12 subjects performing complex kitchen activities. From the results, we observe that the change point module can effectively detect the changes with a low mean absolute error and a low annotation error, which can reduce the problem of label jitter as well. Furthermore, it is very comforting for us to know that AmicroN can predict microactivities with a median F1 score of 0.75 across all the users. We further perform a subjective analysis to observe the practical usability of AmicroN. Here as well, we observe that AmicroN can capture fine-grained details effectively and can utilize it to generate sophisticated microactivity annotations. However, it is highly dependent on the performance of the change point module and the semantic space used. This brings us to the discussion where we first point out that many unnecessary words appear while predicting the microactivities. This is due to the known problem of hubness that plagues any typical zero-shot framework. Finally, the two other areas where the performance of this framework gets impacted are the cases where a subject is multitasking and the overall degree of granularity is not well defined. However, these problems also appear even in the traditional human in the loop annotation based. Understanding these challenges, we propose the following future works where we plan to analyze the fundamental problems and confusions that the human annotators face and how AmicroN can assist them in such cases. Additionally, we also plan to use multimodal information and, if possible, knowledge from open public repositories to develop stronger zero-shot models that can define complex ADLs with ease. Thank you. Please look into our paper for further details.